All. I am Mahalakshmi, working as an assistant professor in physics in Hindustan College of Engineering and Technology. Today we are going to discuss a few topics regarding lasers. Today's topics, let us introduce what is a laser, what are the properties and basic concepts of laser, principle of laser beam, population inversion, pumping action, and the basic components of laser. What is a laser? Laser is an acronym for light amplification by stimulated emission of radiation. Properties of laser beam are the most important properties are its high directionality, high intensity, extraordinary monochromaticity, and its high degree of coherence. Let us see the difference between an ordinary light beam and a laser beam. Ordinary light are not directional, whereas laser beam is highly directional. Ordinary light, the intensity is small, and in laser beam, the intensity is high. Ordinary light angular spread is more, but in laser beam angular spread is less. Ordinary light is not a coherent beam. Laser beam is a coherent beam. In ordinary light the radiations are polychromatic, but in laser beam the radiations are monochromatic. Examples for ordinary light are sunlight and mercury vapor lamp, and laser beams examples are carbon dioxide laser, helium neon laser, etc. And the basic concepts of laser. Consider an atomic system having two levels of energy E1 and E2 such that E2 greater than E1. Let N1 and N2 be the number of atoms in the energy levels E1 and E2 respectively. So when an atom is exposed to light photons of energy h nu, the three distinct process takes place. Stimulated absorption, number two spontaneous emission, and third stimulated emission. So let us discuss one by one. First one, stimulated absorption or induced absorption. The atoms in the ground state E1 are raised to the excited state E2 after absorbing a photon of energy h nu such that E2 minus E1 equal to h nu. This process is called stimulated absorption. When this is represented by the diagram, that is an atom in the ground state E1 is stimulated by a photon of energy h nu to rise to the excited state E2. So this is second diagram after absorption. Let us see spontaneous emission, wherein an atom in the excited state E2 drops by its own without any triggering agent to the ground state, thereby emitting a photon of energy E2 minus E1 equal to h nu. In stimulated emission, an atom in the excited state E2 is made to drop down to the ground state E1 by triggering it with a photon of energy h nu, wherein the output we have two photons. One is because of the inducing photon E1, which is, and the other when the atom in the excited state drops down to the ground state, a photon is induced along with it. So in stimulated emission, one photon if we send at the input, two photons are produced at the output. Comparison of spontaneous emission and stimulated emission. Spontaneous emission, when an atom in a ground excited state E2 goes to the ground state E1 by spontaneously emitting a photon of frequency nu, which is equal to E2 minus E1 by h. This process is called spontaneous emission. When an atom at the excited state E2 interacts with an incident photon of frequency nu and is thereby induced to move to the ground state E1 by emitting a photon of same frequency nu, process is called stimulated emission. The emitted photon can move in any random direction in spontaneous emission. The emitted photon travels in the same direction in which the incident photon is moving in the stimulated emission. The photon emitted from various atoms have no phase relationship between themselves, but the two photons are in same phase with each other in stimulated emission. In spontaneous emission, the radiation given out by such a source will be incoherent. The radiation given out by such a source will be highly intense, monochromatic and coherent. The transition probability for spontaneous emission depends only on two energy state. The transition probability for this emission depends upon the number of atoms in the excited state and the higher energy density of the incident radiation. And the other points are emission of light photon takes place immediately without any inducement during the transition of atoms from the higher energy level to lower energy level, and emission of light photon is by inducement of photon having a energy equal to the emitted photon energy in stimulated emission. In spontaneous emission, polychromatic radiation, but in stimulated emission is a monochromatic radiation. Spontaneous emission is low intense, whereas stimulated emission is high intense, and spontaneous emission is less directionality and having more angular spread during propagation. Example, light from sodium or mercury vapor lamp, whereas stimulated emission has high directionality and less angular spread during propagation. Example, light from laser source. The figure depicts the emission of laser wherein one photon which induces the atom in the excited state to drop down to the ground state emits two photons. These two photons on the other hand produce four photons. Four protons produce 8. 8 produces 16 photon and the chain goes on, and this process is called avalanche multiplication. Let us now discuss what is population inversion. The establishment of situation in which number of atoms in the higher energy state is greater than the number of atoms in the lower energy state is called population inversion. Usually, the number of atoms N2 in the excited state is less than the population of atoms in the lower energy state N1. That is, N1 greater than N2 is called normal population, whereas the number of atoms in the excited state N2, if it is greater than number of atoms in the ground state N1, is called population inversion. That is depicted in the diagram. First diagram where number of atoms in the excited state is less, and the second diagram depicts where the number of atoms N2 in the excited state is greater than the number of atoms in the ground state N1 is called population inversion. So the achieve the population inversion, three conditions must be satisfied. There must be pair of energy levels E1 and E2 separated by desired radiation. The point number 2, there must be a source to supply energy to the active medium. And the third, atoms must be raised continuously to the excited state. So there are different types of pumping. One is optical pumping, wherein the light radiation H nu is used to make the atom from the ground state E1 to raise to the excited state E2 is called optical pumping, that is excitation by photons. This method is used in ruby laser and YOG laser. Number 2, electrical discharge method, that is excitation by electrons, where the electron hits the atom in the ground state E1 and makes a transition to the excited state E2. That is, A plus electron gives A star plus electron, where A star is the same gas atom in the excited state, and the electron, after giving its energy to the atom A and promoting it to excited state, will lose its energy and falls down to the ground state. Example, argon laser, carbon dioxide laser. 3, direct conversion, where electrical energy is directly converted to light energy. Number 4, inelastic collision between atoms, where an electron collides with an atom A and makes the atom A to go down the excited state, and it loses energy and falls down to the ground state. This is process where in this process the excited atom A star will give its energy to the atom B, which is in the same energy level as A star, and this A star will now become A, that is lose its energy after giving its energy to the atom B, and B will be now taken to the excited state and the atom A will fall to the ground state. This type of transition is called RET, which is the abbreviation for resonant energy transfer. Number 5, chemical reactions, where some reactions takes place between two gas atoms, such as hydrogen and fluorine, giving 2HF star. Basic components of laser. Laser has three important basic components, namely active medium, pumping system, and optical resonator. Active medium. The medium at which the population inversion takes place is called active medium. Pumping system. Pumping system is a device. By using this device, population inversion can be achieved in the active material. Third, optical resonator, which consists of a pair of reflecting surfaces with the active medium at the center. The one of the mirror is 100% reflecting and the other mirror is partially reflecting, and the light output from this optical resonator is a high intense beam called laser. Next, let us see the applications of laser beam. The intense heat produced in a small area by a laser beam is used for welding and matching metals and for drilling tiny holes in the hard material. The precise straightness of a laser beam is useful to the surveyors for lining up equipment, especially in inaccessible locations. Consumer products like Blu-ray and DVD players rely on laser technology to read information from the discs. Barcode scanners rely on lasers for information processing. It is the potential energy source for inducing fusion reaction. It can be used for telecommunication along optical fibers. The laser beam can be used to generate three-dimensional images of objects in a process called holography. A laser beam is used to drill small holes in hard metals, and it is used for welding in electronic circuits. Thank you all once again. Thank you.